Another thing I'm going to teach you is how to add two rationals together. The first thing that you want to do when you're adding two rationals together is find a greatest common factor. Just like if you're adding any other fractions, like if you have 1/2 plus 1/4, the only way you can add this together is if you make a greatest common factor, which is 4, and then multiply it by the top number 2. You have 2/4 over 1/4, and then you end up getting 3/4. So that's what we're about to do here, except a little bit more complicated when you're doing it with variables and stuff. But you can't just look at it and know what the greatest common factor is, so you have to first factor out both the bottom equations. See, I taught you all this factoring in the beginning because you need to use it in almost everything you do. If you can't factor, you can't do these problems. Now, for this problem, we're going to start with factoring out the bottom numbers to see, because that usually helps you find the greatest common factor. If you can't see it when it's in standard form, you'll probably be able to find it when it's in factored form. So we're going to start with this huge one right here on the bottom, and we're just going to take that out. So the first thing we're going to look at is to see if it will group. So we're going to look at it, we're going to take these into groups, and again, you want to make sure that the ratio between this leading coefficient and this leading coefficient will have the same ratio as this coefficient and this coefficient. So right here, this one's 1 to 15, and that one's 71 to 105, which is not the same. So now we know that grouping will not work because the ratios are different. So we have to go to the second way of factoring out a 4-term function, which is dividing. So now when you divide, you usually have an x-intercept. So I'm just going to tell you that this has an x-intercept of x equals -1. So we have to divide it by the x-intercept. So put a division symbol here and put the x-intercept solution on the outside. And now we divide it. What times x cubed equals x? What times x equals x cubed? It's x squared. So we have x squared minus it x times 12x equals 12x squared. 3 times 12x equals 36x minus it gives you 0. Drop down the second term, which is 105. Times 35 equals 105. And there's no remainder, so now we're left with this equation up here. But that's not completely factored yet, so let's pull that one out and factor it again. And as I mentioned before, don't forget to put the other solution that we used to get this next to it, because that's part of the solution. We know that x plus 3 is one of the x-intercepts, so that's one of the solutions for this problem. Now it's just a 3-term polynomial inside parentheses, so we need to find something that multiplies to be this and adds up to be this. And that happens to be x plus 7, x plus 5. Okay, so now we have it completely factored out. So let's put this in our new problem. So this is what we have now. Now let's factor out the second bottom number of the other equation. Function. So we have this one. So now we're going to take out this one. Alright, I'm just going to do it right here. Now I forgot to put the x right there. This was supposed to be x squared plus 10x plus 21. So that's what we have right here. And we pull it out, and it's just a regular 3-term polynomial with a value as 1. And it's all positive, so let's just factor it out. Something that multiplies to be this, that adds up to be this. And these two numbers would be x plus 7 and x plus 3. Now that's completely factored out. Let's put it in our equation. Alright, now that we have this all in, including this top number. If you're wondering why I didn't do anything with the top numbers, it's because I could do something with the top numbers, but I'm only trying to find the greatest common factor, which is the bottom number, and plus both of them are completely factored already, so I don't even have to worry about that. But now that we have both of the bottom numbers, you can see what we're missing. See, we have x plus 3 times x plus 7 times x plus 5, and we have x plus 7 times x plus 3, and what can we do to this to make it this? Well, all we have to do is add the x plus 5 on there and times it by that. So, just like with regular fractions like we do, you just times it by the bottom number and times it by the top number. So, I just put in x plus 5 right here next to it, because putting it right next to it just means times, so then it ends up looking just like this on the bottom. And if I do it to the bottom, then I have to do it to the top. So now I distribute the 5 to both of these, and I end up getting 5x plus 25. So now I have that over top, the greatest common factor. So now my problem looks like this. So now that we have the greatest common factor, they both have the same on the bottom, all we have to do is combine these terms together, because we just add both the quantities together, and they both have the same greatest common factor on the bottom. So we add x plus 30, negative x plus 30, and then add the 5x plus 25. And then we combine like terms. The two x's add up to 4x, and then the two whole numbers add up to 55. So we end up with 4x plus 55 on the top. And then once you get the answer on the top, you just put the previously figured out greatest common factor on the bottom, which is x plus 5, x plus 3, x plus 7. So now you have this. And this is our final answer. So, back to the previous question. What is negative x plus 30 over x cubed plus 15 x squared plus 71x plus 105 plus 5 over x squared plus 10x plus 21? Well, the answer is 4x plus 55 over x plus 5 times x plus 3 times x plus 7. And that's how you would add two rationals together.